resistance of conductor. So what is this resistance of the conductor? So the opposition offered by the conductor for the flow of the current through it is called a resistance. See, the opposition. అరే మ్యూట్ చేయరా హర్ష, అందరూ మ్యూట్ చేయి నన్ను కాకుండా. The opposition offered by the conductor
Sir, media. Recording stop.
The opposition offered by the conductor for the flow of current is called resistance. So this is what is meant by resistance now. The opposition offered by the conductor for the flow of the electric current is called a resistance. So resistance of the conductor depends on what factors? See, resistance of a conductor depends on, so conductor resistance దేని మీద డిపెండ్ అవుతుంది? So depends on length and area of the cross section. Depends on, there is a length and area of length area of length and area of the cross section. So వీటి మీద డిపెండ్ అవుతుంది. ఎవడరా సో length and area of the cross section వీటి మీద డిపెండ్ అవుతుంది. సో దిస్ రెసిస్టెన్స్ ఎలా డిపెండ్ అవుతుంది అంటే, resistance is directly proportional to length and inversely proportional to area of the cross section, or is directly proportional to L and inversely proportional to A. That is, అప్పుడు నేనేం రాయొచ్చురా ఇక్కడ, R is equal to some constant rho L by A. This is the resistance. R is equal to rho L by A. That is called resistance. So means this rho is here. What is this? Rho is a resistivity. Rho we called resistivity, or otherwise called as specific resistance. Resistivity or specific resistance. Resistivity or specific resistance. So R depends on dimensions but not rho. So R అనేది దేని మీద డిపెండ్ అవుతుందంటే, R depends on R depends on dimensions, but not rho. R depends on dimensions. But not rho. And the rho does not depends upon the dimensions. So R is depends upon the dimensions. Or there may depend out dimensions may depend out. R is directly proportional to length and inversely proportional to area of the cross section. So, but rho is not depends upon the dimensions. Dimensions may depend on. So rho is depends on nature of the material. Here, rho depends on nature of material. So resistivity is depends on nature of the material, but R is depends upon the dimensions. Length మీద area of the cross section మీద depend అవుతుందిరా. Suppose if here there is, if L is equal to 1 meter, A is equal to 1 meter square, then R is equal to what is it? Rho. The resistance is equal to resistivity. When the resistance is equal to resistivity, ante what is it? So L is equal to 1 meter, A is equal to 1 meter square, then R is equal to rho. So this is what is meant by resistance. So what is the SI unit of resistance? The SI unit of resistance is unit of
Ohm.
resistance. SI unit of resistance is ohm. Is the SI unit of resistance. The symbol is like this. This is the symbol of ohm. Ohm ki symbol is. SI unit of resistance is ohm. The symbol is that is the symbol of ohm. Okay. And now see that there is other forms of resistance. Resistance other forms ela rastam. First, write this down. What is not a resistance? So resistance is nothing but the opposition. One minute. 1 minute. 1 minute.
Unmute.
So this is a resistance. The opposition offered by the conductor for the flow of the current is called resistance. So resistance of the conductor depends upon the length and the area of the cross section. That is, R is proportional to L by A. R is equal to rho L by A. So rho is equal to resistivity or specific resistance. So R depends upon dimensions but not rho. So rho is depends upon the nature of the material. SI unit of resistance is ohm. So L is equal to 1 meter, A is equal to 1 meter square, then R is equal to rho. Right? This is. Write down. Yeah. ఇక్కడ చూడండి రా. Other forms of resistance. See. Other forms of resistance. So what are the other forms of resistance? ఇప్పుడు చూడండి రా. You know, R is equal to rho L by A. R is equal to rho L by A. ఇలా తీసుకున్నాం. So R is equal to rho L by A. You know, mass is equal to what is it? Mass is equal to volume into density. Density ని D అని రాస్తాను.
Yes, sir.
Density I called D. ఎందుకంటే ఇక్కడ రెసిస్టివిటీని రో అన్నాను కదా, అందుకని డెన్సిటీని D అని రాస్తాను. So volume is equal to what is that? Area into length into density. అంటే mass is equal to ALD రాయొచ్చు. So mass is equal to ALD రాస్తే, now here there is a resistance, different other forms of resistance. So resistance is equal to what is it? Resistance R is equal to rho by A into L. Rho by A into L. Are ఇక్కడ in terms of this mass rho by A into L here, in terms of this mass, L is equal to ఏం రాసుకోవచ్చురా, M by AD. అంతేగా, M by AD. We can write like this, M by AD. So now here there is resistance is equal to rho by A. This is rho by A into L is equal to M by AD. అప్పుడు నేను resistance is equal to M rho by A square D, we can write. M rho by A square D. M rho by A square D, we can write like this. Or in terms of the volume తీసుకున్నా, suppose this is in terms of what is it, mass. In terms of volume తీసుకున్నా, resistance is equal to rho by A. You know that volume is equal to what is that? Volume is equal to area into length. Length is equal to volume by area. So this we can write that volume by area this is. So R is equal to rho into volume by what is that? A square is there. Volume by A square. ikkade రాయొచ్చురా, mass by density is equal to volume. So అక్కడ కూడా రాయొచ్చు నేను, mass by density is equal to volume. In terms of the volume is this one. And here in terms of the mass, in terms of the volume, here also here there is a resistance is inversely proportional to A square, and here also resistance is inversely proportional to A square. Okay, so resistance is inversely proportional to A square, and mass కూడా consider చేస్తే you can write that mass is consider resistance is proportional to M by A square. So resistance is proportional to inversely proportional to A square means here I have to write that R1 by R2 is equal to A2 by A1 whole square like this. A2 by A1 whole square. And also this resistance is inversely proportional to pi small r square whole square. ఇక్కడ capital R అంటే resistance, small r అంటే what is it? Radius of curvature. Smaller is radius of curvature. So here there is, from this we can write that R is inversely proportional to pi square R power 4. So this R is inversely proportional to R power 4. So R is inversely proportional to R power 4 means R1 by R2 is equal to R2 by R1 whole power 4. Okay, so capital R ante resistance ra, this we called resistance antam. This we called the radius of cross section. Radius of cross section. Radius of cross section. So this is resistance in terms of that mass and volume. And now see that. So this resistance here, R is equal to, resistance R is equal to rho L by what is that A? Rho L by A. From this, we can write that A is equal to what is that? M by LD. A is equal to M by LD. Now this resistance is equal to rho L by M by AD. So this is R is equal to rho L. Okay. So M by what is that? LD.
LD, sir. LD.
LD. So this is a LD by M is there. Now this rho is R is equal to rho L square D by M. This is L square D by M. Okay. Rho L square D by M. And this R is equal to rho L square by D by M is equal to what is that? Volume. In terms of the volume. In terms of the volume. Are ikkada chudandi. So this R is directly proportional to L square by M. R is directly proportional to L square by M. So this R is directly proportional to L square if the wire is stretched. ఇవన్నీ ఎప్పుడు తీసుకుంటామంటే సో ఎప్పుడు దట్ వాల్యూమ్ రిమైన్స్ కాన్స్టెంట్ ఉన్నప్పుడు వాల్యూమ్ రిమైన్స్ కాన్స్టెంట్ ఎప్పుడు ఉంటుంది సపోజ్ ఇక్కడ ఒక వైర్ ఉందిరా సో వైర్ ఇస్ దేర్ దీని ఏరియా ఆఫ్ ది క్రాస్ సెక్షన్ A1 దీని లెంత్ L1 దీన్ని స్ట్రెచ్ చేసామంటే ఈ వైర్ లెంత్ ఏమైంది పెరిగిద్ది సో వైర్ లెంత్ పెరిగినప్పుడు ఏరియా ఆఫ్ ది క్రాస్ సెక్షన్ ఏమైంది తగ్గిద్ది ఏరియా ఆఫ్ ది క్రాస్ సెక్షన్. So this length is L2, area of the cross section A2. But what is the constant here ante ee renditiki what is constant ante volume is a constant. Volume constant ga untundi. Appudu volume ila stretch chesi suppose if the wire is stretched. Ikkada wire is stretched. Ela adugutaro chudandi. If the wire is stretched like this, a wire of resistance, see, a wire of resistance, a wire of resistance resistance 2 ohms is stretched so that its length is doubled. Its length is doubled. Then the resistance of then the new resistance is. Are chudandi, he is mentioned about that length. He is not mentioned the area. Area ni mention cheyaledu. Length ni mention chesadu. లెంత్ మెన్షన్ చేసాడు ఏరియాని మెన్షన్ చేయలేదు కాబట్టి సో నువ్వు ఏరియా గురించి తెలియనప్పుడు ఏరియా డెఫినెట్ గా ఏమవుతుంది స్ట్రెచ్ చేసినప్పుడు ఏరియా ఏమవుతుంది తగ్గిపోతుంది ఏరియా మారిపోతుంది ఏరియా కాన్స్టెంట్ కాదు ఒకవేళ ఏరియా కాన్స్టెంట్ అయితే ఆర్ ఇస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు ఎల్ అనేవాడివి బట్ హియర్ ఏరియా ఇస్ నాట్ కాన్స్టెంట్ బట్ వాట్ ఈస్ కాన్స్టెంట్ ఇన్ దిస్ కేస్ వాల్యూమ్ ఇస్ కాన్స్టెంట్ సో వాల్యూమ్ కాన్స్టెంట్ కాబట్టి ఆర్ ఇస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు ఎల్ స్క్వేర్. So R is directly proportional to L square means this is R1 by R2 is equal to L1 by L2 whole square. So this R is equal to how much? 2 and this is R2. This is L by 2L whole square this is. So now what is that here? This 2 by R2 is equal to 1 by 4 and here R2 is equal to how much? 8 ohms. That is R2. R2 is equal to 8 ohms.
Sir, board clear ga le sir.
Sir, full blur, sir. Board.
Sir, full.
Wait చేయండి
Adjust.
వెయిట్ చేయండి ఇంకా మనకు ఛాన్స్ లేదు వైఫై లేదు
ఓకే సార్
వెయిట్ చేయండి
Okay, sir.
అప్పుడప్పుడు
Wait
అలా
చేయండి
అవుతుంది,
అన్న.
మళ్ళీ క్లియర్ గా వస్తుంది సార్.
అదే అదే
అప్పుడప్పుడు
అందుకే వెయిట్
జరుగుతుంది.
చేయి.
సార్ బ్లాక్ తో రాయండి సార్ కొద్దిగా బాగా
సార్ బ్లాక్ కలర్
కనబడుతుంది.
కొంచెం బాగుంది సార్.
రెడ్ తో రాస్తా
బ్లాక్ అయితే లైట్ గా కనపడుతుంది సార్, రెడ్ కనపడలేదు సార్.
రెడ్ అసలు కనిపించట్లేదు.
కనిపించలేదా?
క్యామ్ క్లీన్ చేయండి సార్, ఒకసారి క్యామ్ క్లీన్ చేయండి సార్.
క్యామ్ క్లీన్ చేయాలా? క్యామ్ క్లీన్ చేయాలా?
ఒకసారి క్లీన్ చేయండి సార్.
దానికి దీనికి కాదు, నెట్వర్క్ రా, క్యామ్ కాదనుకుంటున్నా.
ఇప్పుడు క్లియర్ గా ఉంది
ఓకేనా?
సార్.
ఇప్పుడు
ఇప్పుడు
క్లియర్
బాగుంది
ఉంది,
సార్, క్లియర్ ఉంది సార్.
క్లియర్ ఉంది సార్.
అంటే క్యామే ప్రాబ్లమా?
క్యామ్ మీద
నాకు
డస్ట్
తెలియలేదురా, అది తెలియలేదురా.
సార్, అది లైటింగ్ ఎఫెక్ట్ పడుతుంది సార్, అందుకు కనుక్కున్నాం.
అరే చూడండి ఇక్కడ wire of resistance 2 ohms is stretched to double its length. Then its new resistance is, so new resistance is అంటే మనం ఏం రాయాలి ఇక్కడ, వాల్యూమ్ కాన్స్టెంట్ కాబట్టి R is directly proportional to L square. R1 by R2 is equal to L1 by L2 whole square. Is 2 ohms by R2. L1 is L, L2 is 2L whole square. So this is 2 by R2 is equal to 1 by 4. R2 is equal to 8 ohms. అర్థమైందిరా? ఎరా
సార్ అర్థమైంది సార్.
అర్థమైందా?
బ్లర్ సార్.
కంప్లీటెడ్ సార్.
సార్ కొంచెం బ్లర్ గా ఉంది సార్.
బ్లర్గా ఉందా ఇంకా? మళ్ళా ఒకసారి ఇంకేముందిరా మమ్మల్ని చెప్పారుగా.
సార్ స్క్రీన్ సార్, స్క్రీన్ షేర్ చేయండి.
స్క్రీన్ మళ్ళా ఒకసారి
స్క్రీన్ షేర్ చేసి చెప్పండి సార్.
స్క్రీన్ షేర్
అంటే
సార్ ల్యాప్టాప్ లో
స్క్రీన్ షేర్ చేసి చెప్పండి సార్.
ఫుల్ బ్లర్ సార్, ఏం అర్థం కావట్లేదు సార్.
సార్ స్క్రీన్ షేర్ వద్దు సార్.
స్క్రీన్ షేర్ అంటే దానికి నెట్ లేకపోతే అవ్వదు రస్తా.
పెద్దగా రాయండి సార్, సరిపోతుంది సార్.
సార్ క్వశ్చన్ సార్ చెప్పండి సార్.
లావ్ లావ్
సార్ పెద్ద పెద్ద రాయండి సార్.
తిక్కుగా రాయండి సార్, సరిపోతుంది.
So what is that conductance and conductivity? What is conductivity? What is conductance? Conductance అంటే ఏంటి? Conductivity అంటే ఏంటి? అని చూద్దాం రా. బోర్డు దుడుతాం రా, కెమెరా దుడుతాం. ఓకేరా?
ఓకే సార్.
చూడండి రా. సో లాగా రాస్తున్నాను చూడండి రా. వాట్ ఈస్ మెant బై కండక్టెన్స్? ఓకేరా?
ఓకే సార్.
సరిపోద్దా?
ఓకే సార్, ఓకే సార్.
ఓకే సార్.
Conductance. So conductance that we called G. Conductance is G. So conductance means the reciprocal of resistance. Reciprocal of resistance. Reciprocal of resistance is called conductance. Reciprocal of resistance is called conductance. So this conductance
G is equal to 1 by
so G is equal to 1 by R. This is the reciprocal of resistance is called conductance. G is equal to 1 by R. And SI unit of this one is SI unit of this one 1 by ohm, or otherwise this is MHO 1 by ohm, MHO, or otherwise called as Simon. And the MHO and or what is that? Simon. So this is the SI unit of Simon. Is the SI unit of what is that? Conductance. Conductance is SI. And what is meant by conductivity? Conductivity. What is conductivity? So this conductivity is sigma I call. Conductivity is a sigma. So the reciprocal of resistivity is called conductivity. The reciprocal of resistivity is called the reciprocal of resistivity is called what is that? Conductivity. Conductivity. So this conductivity is equal to 1 by rho, 1 by resistivity. Conductivity means 1 by resistivity. So what is the SI unit? SI unit of this one is, see, resistivity is equal to, you know that R is equal to rho L by A. Rho is equal to RA by L. But R unit entra ohm. This is ohm. Then unit enti meter square by meter. So this is equal to ohm meter is the unit of resistivity. Resistivity ki unit to ohm meter. So resistivity ki unit to ohm meter aithe ee deeniki conductivity ki what is the SI unit? SI unit of conductivity. So this is 1 by ohm meter. 1 by ohm meter. And this is MHO meter inverse. MHO is nothing but what is it? Simon meter inverse is the SI unit of conductivity. Or conductivity SI unit to Adira. Okay. So write down quick. త్వరగా రాయండి. కనబడుతుందా? బానే కనబడుతుందా?
సార్ అర్థం చేసుకోవచ్చు సార్.
అంటే బ్లర్ గా ఉందన్నమాట. ఓకేరా. నెక్స్ట్ Ohm's law. Ohm's law. See. Ohm's law. See that at a constant temperature, when the temperature of the conductor is kept constant, at constant temperature, the strength of the electric current, the strength of electric current flowing through the conductor through the conductor is directly proportional to potential difference between two ends of the conductor. Two ends of conductor. So at constant temperature, the strength of the electric current flowing through the conductor is directly proportional to potential difference between the ends of the conductor. అంటే ఇప్పుడు ఈ కండక్టర్ ఇలా తీసుకుంటే ఈ కండక్టర్ వాట్ ఈస్ ఇట్ there is a potential difference between the two ends of the conductor. So because of this potential difference, the current is passing through the conductor. So this current, according to Ohm's law, is directly proportional to potential difference between the ends of the conductor. So temperature is constant. Temperature alone constant. So I is equal to some constant 1 by R into V. So this is 1 by R into V. I is equal to some constant is there. So that constant is 1 by R. So 1 by R into V, that is. Okay. So this 1 by R is equal to what is that? 1 by R is equal to what is it? What is it? Conductance, that is G. So G into V. V is equal to I is equal to GV. Okay. And one more, we have to write that here. V is directly proportional to I also. The potential difference between the two ends of the conductor is directly proportional to the strength of the electric current. That is also we have to write. So V is directly proportional to I. V is equal to some constant R into I. So this is V is equal to, what is it? So V is equal to IR. This is Ohm's law. So V is equal to I into R, that is current into resistance. This we call Ohm's law. So if the substances obeys this law, that substances are called ohmic substances. The substances which does not obey that law, that substances are called non-ohmic substances. వాటిని ఏమంటాం మనం non-ohmic substances. అంటే ఈ ఫార్ములాని ఎలా తీసుకోవాలి, ఎలా రాయాలి ఈ ఫార్ములా? సో ఒక ట్రయాంగిల్ తీసుకుంటున్నాం రా, అంటే చిన్నపిల్లలకు నేర్పే విధంగా నేర్పుతున్నా చూడండి. జనరల్ గా ఇవన్నీ చిన్నపిల్లలకు నేర్పుతారు. ఇవి 10th ఇప్పుడు తీసుకోండి, VIR ఇలా నేర్పుతారు. VIR అంటే ఏంటి? V is equal to IR అని. V is equal to IR అని. I is equal to, what is it? I is equal to V by R. R is equal to, what is it? V by IR. By ఉంది కదా. So R is equal to, what is it? V by I. V by I. So these are the names. These are the relations among this. ఇవి సో ఓమ్స్ లా. ఓమ్స్ లా అది. ఇప్పుడు ఓమ్స్ లా ఇలా ఉంటే హియర్ వాట్ ఇస్ ద గ్రాఫ్ ఫర్ దిస్ ఓమ్స్ లా? అంటే ఇప్పుడు నేను సపోజ్ ఇక్కడ కరెంట్ తీసుకున్నాను. దిస్ ఈస్, వాట్ ఇస్ దట్ కరెంట్? దిస్ ఈస్ V. So generally the graph is a straight line. This is a, so slope is equal to tan theta. Slope means, what is it? M actually. This is a tan theta. Tan theta is equal to I by V. Antega? So I by V. Tan theta is equal to I by V. So I by V is equal to, what is that? Conductance. This directly gives the slope, directly gives conductance. Conductances. So in graph can try this thing. This is the graph. Suppose this is the graph. So here there is a V. This is I. It is a straight line. This is a theta. And the slope is equal to M. That is equal to tan theta. That is equal to V by I. So M directly gives what is that? Resistance. Slope directly gives resistance here. అక్కడ స్లోప్ ఏమి ఇస్తుందో మనకి రెసిస్టెన్స్ ఇస్తుంది స్లోప్. ఓకే, స్లోప్ డైరెక్ట్లీ గివ్స్ రెసిస్టెన్స్. రైట్? బాగా బ్లర్ గా ఉందమ్మా. ఒకసారి చూపుతాం. వాడు చెప్పాడుగా, చూద్దాం కెమెరా. ఇప్పుడు చూడరా, చూసాను కెమెరా.
ఓకే సార్.
ఓకేనా? రైట్ రైట్. రాయండి రా, నేను కొన్ని థియరీ పాయింట్స్ చెప్తాను, రాయండి. అయిపోయిందిరా. అడ్జస్ట్ అవ్వడమ్మా కొంచెం. See, there is ఓమిక్ ఓమిక్ and ఓమిక్ and non-omic, omic and non-omic conductors, omic and non-omic conductors. So what are omic conductors and what are non-omic conductors? Omic conductors, omic conductors. See, the substances which obeys Ohm's law, the substances are conductors. The substances which obeys Ohm's law are called ohmic conductors. Which obeys Ohm's law are called ohmic conductors. And for ohmic conductors, see, for ohmic conductors, VI graph is a straight line. VI graph is a straight line. Now మనం చూపించాం. So ఇలా suppose V is there, I is there. So this is the graph, straight line graph. See here, what is it? V changes, I changes, but R remains constant. అంటే రెండు ఒకే విధంగా ప్రపోర్షనల్ గా చేంజ్ అవుతాయి కాబట్టి, సో R is equal to V by I కాబట్టి V is equal to IR, R is equal to V by I. సో ఇప్పుడు R is equal to V by I రా. రెండు ఒకే విధంగా ప్రపోర్షనాలిటీ గా చేంజ్ అవుతాయి. ఇది ఎంత చేంజ్ అవుతుందో ఇది కూడా అంతే చేంజ్ అవుతుంది. ప్రపోర్షనాలిటీ ఉంటుంది కాబట్టి V changes, I changes, but R is constant. R ఎలా ఉంటుంది? Constant గా ఉంటుంది. Okay, right. And non-ohmic conductors are non-ohmic devices. Non-ohmic devices. See, non-ohmic. Okay, so this is a non-ohmic conductors or devices. Non-ohmic conductors or devices. Non-ohmic conductors or devices. Okay, see, non-ohmic conductors or devices, the substances which does not obey Ohm's law are called, does not obey Ohm's law are called non-ohmic conductors. Non-ohmic conductors. See, for non-ohmic conductors, VI graph is not straight. VI graph is not a straight line. Straight line called VI graph. All metals, all metals are ohmic and non-ohmic. Thermistor. So this is a thermistor. These are some of the non-ohmic devices. Some of the non-ohmic devices. Suppose the curve is VI curve is not a straight line. Suppose PN junction diode is there. PN junction diode. So PN junction diode, the graph is like this. This is the graph. Thermistor, this is the graph. Thermistor, the graph is like this. Yeah. So these are the non-ohmic devices. Non-ohmic devices are there. Okay. ఏంట్రా బోర్డు బాగా బ్లర్ గా ఉండడం వల్ల ఓకేరా
సార్ క్లియర్.
రైట్ రా రైట్ ఇక్కడ మీరు ఏం రాస్తారంటే non-ohmic devices V changes, I changes are also changes. For non-ohmic devices ki V changes, I changes are also changes. V changes, I changes are also changes. అరే పవర్ లేదురా, పవర్ లేకుండానే ఆ తలుపులను తీసి చెప్తున్నా. నెట్ ఏంటంటే చెప్పారుగా మొబైల్ డేటా అది.
సార్ ఇప్పుడు పర్వాలేదు సార్, అర్థం అవుతుంది సార్ చూడడానికి.
అయిపోయిందిరా. Okay, so Rajendra, the formula V is equal to IR. The formula V is equal to IR is applicable. Formula V is equal to IR is applicable for finding resistance, or to find the resistance for both ohmic and non-ohmic devices. For both ohmic and non-ohmic devices. Okay, current వచ్చింది. For both ohmic and non-ohmic devices. Ohmic and non-ohmic devices. Yeah. So now I will come to that. There is a combination of resistors. Combination of resistors. See. Combination of resistors. In the combination of resistors, the first one is the series combination. First one is series combination. What is the meaning of series combination? Suppose the three resistors, it is R1, R2, R3 are connected like this, end to end connection. End to end connection, and this end is what is it, connected to positive terminal, and the last end of the last capacitor, second end of the last capacitor connected to negative terminal. This combination is called what is it, series combination. And this is a V potential difference. And see, the potential difference is splits, is a divide across the resistors. The total potential difference is divides. So this is V2 and it is V2 in the series combination. And you know the current is the same. The current is the same here. Current, this is the current I is coming like this. So I1 is equal to I only. I2 is equal to I only. I3 is equal to I. The current remains constant in the series combination. So current remains constant in the series combination. And how to find out the effective resistance? Effective resistance means, see that, what is the effective resistance? So effective resistance is nothing but if you replace one resistance by all these three resistances in the series combination, that we call to effective resistance in the series combination or equivalent. And this is the pattern, right? This is V. and it is I. So you know, according to Ohm's law, V is equal to IR. V is equal to IR here, and V is equal to I into R. What is that? Equivalent. R equivalent. Here, see that there is a V1 is equal to I1 R1, and V2 is equal to I2 R2. V3 is equal to I3 R3. So you know, in the series combination, we know that in series combination, in series combination. So V is equal to what is it? V1 plus V2 plus V3. V means I into R equivalent is equal to this is I1 R1 plus I2 R2 plus I3 R3. But in series combination, I1 is equal to I2 is equal to I3 is equal to I only. Same current. So that here, what is? So this I R equivalent is equal to, what is it? I1 means I into R1 plus I into R2 plus I into R3. So this I is taken common. R1 plus R2 plus R3 is equal to I R equivalent. So this is cancelled. R equivalent is equal to R1 plus R2 plus R3. This is the equivalent resistance in the series combination. You know, in the series combination here, in series combination, I1 is to I2 is to I3 is equal to 1 is to 1. Same current is passing through all the resistors, and V1 is to V2 is to V3 is equal to P is equal to IR. I is same. What is it? R1 is to R2 is to R3. This is in the series combination. Series combination. Okay, na? Right, na? Clear ga undra?
Sir, clear, sir.
అయిపోయిందిరా completed ఓకే ఇప్పుడు చూడండి Yes, there is suppose two resistors are connected in series. ఇదేంట్రా V1, this is V2. ఇప్పుడు నీకు తెలిసిన దాని ప్రకారం I1 is equal to I, I2 is equal to I, సేమ్ కరెంట్. ఇప్పుడు దీనికి ఎఫెక్టివ్ రెసిస్టెన్స్ ఏం రాస్తావు? ఎఫెక్టివ్ రెసిస్టెన్స్ అంటే RS is equal to R1 plus R, అంటే సిరీస్ కాంబినేషన్ RS అంటే this means series combination. RS is equal to R1 plus R, right? So RS is equal to R1 plus R2. Sure. So RS is equal to R1 plus R2. ఇక్కడ మనకి, so what is the potential due to this potential in the first resistor and potential in the second resistor? So potential across the first resistor, potential across the first resistor. అంటే ఇక్కడ ఏం రాయొచ్చు నేను? I1 is equal to I1 అంటే I is equal to what is it? V by R, V1 by R1. ఇక్కడ ఏంట్రా? V by R effective అంటే S, effective resistance. So this is V1 by R1 is equal to V by R1 plus R. ఇప్పుడు ఏమవుతుందిరా? V1 is equal to R1 by R1 plus R2 into V. This is the potential across the first resistor. సో ఇంకా నేను మళ్ళా డెరివేషన్ చేయాల్సిన అవసరం లేదు, మళ్ళా అలా ప్రతిదానికి అలా చూపించాల్సిన అవసరం లేదు. సిమిలర్లీ పొటెన్షియల్ across the second resistor, potential across the second resistor. So potential across the second resistor, V2 is equal to R2 by R1 plus R2 into V. This is R2 by R1 plus R2 into V. So this is the potential across the second resistor. Suppose here if two identical resistors each of resistance R in series, effective resistance to R. Okay, suppose if an identical NR. రైట్ త్వరగా రాయండి. సో ప్యారలల్ కూడా చెప్పేసి ఆపేస్తాను, ఉడికిపోతున్నాను ఇక్కడ. ఎస్ parallel combination. Suppose there are three resistors are connected like this. V. So in the parallel combination, the potential across the first one is V only. The potential across the second one is V only. The potential across the third one is V1. So potential is remains constant. But the current is splitting here. Current is divides. Current emotionally divided. I will come like this. So this I, the current I1 is flowing through that branch. I2 is flowing through this branch. I3 is flowing through this branch. So now the equivalent resistance. Equivalent resistance means this is the equivalent resistance. Means all three are replaced by a single resistor in the parallel combination. So this is R equivalent, and this is a battery, and the potential is V, and this is the current is I. So V is equal to IR. IR effective equivalent. So I is equal. So V by R equivalent. See here, I1 is equal to 2 is equal to V2 by R2. I3 is equal to V3 by R. Right. So here, what is that? In parallel combination, I is equal to I1 plus I2 plus I3. So I is equal to I1 plus I2 plus I3. See, so I is equal to what is that? V by R effective, R equivalent is equal to V1 by R1 plus V2 by R2 plus V3 by R3. But V1 is equal to V2 is equal to V3 is equal to V. So this V by R equivalent is equal to V by R1 plus V by R2 plus V by R3. So these are cancelled. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R. So in parallel combination, in parallel combination, see that the ratio of the potentials V1 is to V2 is to V3 is equal to 1 is to 1 is to 1. Ratio of the currents I1 is to I2 is to I3 is equal to, current is equal to V by R, that is 1 by R1 is to 1 by R2 is to 1 by R2. Right. Completed, right? Yes. Okay. Yeah, suppose here two resistors are connected in parallel. The potential is the same, but the current I, I1, I2. Again, this is I. See the effective resistance. So 1 by R effective means 1 by RP. Which means here we can write that RP is equal to R1 plus R2. So potential is remains constant. Current across first resistor. Current across the first resistor. So what is the current across the first resistor? See. So what is the current across the first resistor? So current across the first resistor means, see this is what is that? What is constant here? V1 is equal to V. V is equal to I1 R1. This is IRP. So I1 R1 is equal to RP is equal to what is it? R1 R2 by R1 plus R2. So this R1 and R1 is cancelled. I1 is equal to R2 by R1 plus R2 into I. This is current. Yeah, current across the second resistor. Current that is. So now, see, there is here, if two resistors are in parallel. So two identical resistors are in parallel. RP is equal to R into R by 2R. R by 2. Similarly, if n identical resistors are in parallel, n identical resistors are in parallel. So RP is equal to what is that? R by N. Okay. That is. Okay, completed. Okay, ma. మీకు వర్క్ పెడతాను వర్క్ చేయండి రైట్ వర్క్ పెడతానమ్మా ఇప్పుడే పెడతాను వర్క్ వినోద్ డౌట్ నువ్వు కాల్ చేయరా నేను చెప్తాను రా వినోద్ నేను చెప్తాను రా అంటే ఒక ఆఫ్టర్ 5 కాల్ చేయరా వినోద్ స్క్రీన్ షాట్ పంపించరా స్క్రీన్ షాట్ పంపించు బాయ్